Now, in class, here's the graph that we constructed for y doubling when x changes by this much. Okay, and we see that we use that increment for our x changes. And when we draw the y equals 1,000 line here, I drew that line. Then one of the class drew this line for y equals $2,000 and figured out that, well, the doubling time has to be from where we started here to where we hit the $2,000 mark here. So this was the doubling time, and this matches this almost perfectly. Now we also constructed the graph for y triples when x doubles. That would be this graph. We did that previously in class. And then we constructed the graph where y quadruples. Y increases by a factor of 4 when x doubles. This is because some people are still a little fuzzy on that notion. I think everybody has it now. Okay, and we get the graph. Now, y increases by a factor of 4. I once had a student, good kid, he's a CPA somewhere now, a very lively, energetic, and I said, okay, now what do we call it when something increases by a factor of 4? Well, he knew doubles, triples. He couldn't think of quadrupling. And he sat there and thought for a minute. He said, it forples. I've had that in my mind ever since. Okay, so I call that the forpling graph. Not sure whether it should have a U in there or not. I've spelled it without the U because I think it looks neater. Okay, but this is a graph where y quadruples every time x doubles. And the way this graph was constructed, we started with an axis. And I just had somebody come up and put a point on the board. So a point maybe about here. Okay, now, if y increases by a factor of 4 when x doubles, what do? Well, have people come up one at a time like they did before, just like we did with the tripling graph. So here's our first x, here's our first y. If we double this x, that means we come out to about here. And if we forple or quadruple our value of y, well, it ends up about up here someplace. So we get a point, might actually be up in this graph a little bit, but we'll allow that. Now, if we want to quadruple that once more, 1, 2, well, it gets up too high, can't reach it. So I can't go that way anymore. Now, how are we going to do this? We've only got 2 points on the graph. Well, people understood, and people just spontaneously did this. Well, okay, let's go to the left. Let's cut this in half, which means we're going to cut the y value by a factor of 4. Okay, we're going to get 1/4 the y value, or if you like, we're going to reciprocal it, the reciprocal of a quadruple. Okay, so we can do that easily. We just divide this in half and divide this in half, and we get a new y value. And this goes with this x value, so we can easily locate that point on the graph. It'll be right about here. And then we cut that in half. And we got to cut this down by a factor of 4. Well, that's going to get pretty small. That's going to get down really pretty close to the x-axis. Okay? So now what's our graph going to look like? Well, it's going to at least start here and go up here and go up here and go up pretty steeply. Because that's a pretty good curve. Now I started at this point, but clearly we can keep moving to the left. We could cut this x value in half, and the y value would be cut down to 1/4, and that'd be impossible to draw with a piece of chalk. And we could cut the x value in half again, and the y value would be cut by a factor of 4. So what happens here? Well, one question that I put on the homework was, does it make sense to include the point 0, 0 on this graph? And let's think about that. If we keep cutting x in half, are we ever going to reach 0? Well, no, because half of something is not zero. Half of whatever we got is half as big, but it isn't zero. So our halves are never going to reach zero. And the same thing if we cut the x values in fourths. If we take a fourth of something, we certainly get something that's not zero. And then if we take a fourth of that, well, same thing. It's something, it's not zero. But these values approach zero very quickly. So what I said over here in terms of this graph is, well, certainly x is going to approach zero. You see up here where we were cutting the x in half and half and half and half and half, and we could have done that a couple more steps. And as we were moving toward the origin, we were cutting our y by a factor of 3. Well, clearly, that's going to make the y values approach 3 as the x values, the y values are going to approach 0 as the x values approach 0. So I'm going to say x approaches 0, y approaches 0. So the graph is going to approach the point 0, 0. So it makes very good sense to include the point 0, 0 on the graph. So I can start the graph at the origin and pick it up where I had it. And the graph goes all the way back to the origin, and it makes perfect sense to do so.